Hi students. Good morning everyone. Okay. So I think my video and screen is also clear to everyone. Morning all. So I am back again after nearly 1 week of time. So I was just going through some work. So that's why I have not done any videos of CET and all. Okay. So how are you all? I think all of you are very good and fine. Quickly tell me everyone, voice and screen. I think everything is clear. So today I am going to start the concept of continuity. Okay. So your CET related concepts I am going to solve, and here I am going to take continuity chapter. So in that continuity chapter I am going to take some of the questions which have occurred in your last year, as well as which are very important like things for your competitive exams. Okay, because here we can say that we can expect one question from continuity. Okay, but we can't say only these questions will be asked and these questions are going to be important, like that we can't say. But here the concept continuity is very important, and definitely from this there will be one question in your CET. Okay, so that's why be careful, understand the concept clearly, solve as much as problems possible so that you can crack it. Clear? So good morning all of you, and welcome to this chapter, that is continuity. Okay, so we shall start the class. Quickly give me the thumbs and smiles so that I can start the class, and I can also see that you all are very much happy by seeing me after so many days. Okay. Okay, so let us start with the first problem, continuity of a level 1 kind of problems. Clear? So objective level 1 classwork problems. Okay, so you just see the first question. There is f of x given by tan x divided by x. There is f of x given by tan x divided by x. F of x given by tan x divided by x, where x is not equal to 0. Where x is not equal to 0 and f of 0 is equal to 1. F of 0 is equal to 1. Then f of x at x equal to 0. They are asking. Okay, so they have given the function f of x tan x by x at x equal to x not equal to 0, and they have given f of 0 equal to 1, and they have given f of 0 equal to 1. Then f of x at x equal to 0, what happens, they are asking. Okay, so first option is continuous, second option is discontinuous, third option is not determined, and fourth option is none of this. So my dear students, in the first year syllabus you may have learned limit theta tending to 0 sin theta by theta equal to 1. Okay, so and here before going to continuity chapter you must know some basics, that is the function is going to be continuous. The function is going to be continuous if LHL equal to RHL is equal to f of a, and LHL equal to RHL is nothing but your limit extending to a f of x. Okay, so if these conditions satisfy, we say that the function is continuous. So here they have given tan x by x, so for that you just remember your theorem, that is sin theta by theta is equal to 1. This is applying for same for theta by sin theta, tan theta by theta, that all things you have to remember. So using that concept, you can say that directly by looking at the problem only, you can say that it is going to be continuous. Okay, you no need to solve, or you no need to take a pen in hand, because if you know the concept that continuous is LHL is equal to RHL equal to f of a, and it is going to be LHL equal to RHL, that means limit extending to a f of x. And if you know this result, and if you remember that result, by remembering that result directly, you can say that at x equal to 0, this function is going to be continuous. This function is going to be continuous. See, here we have not yet solved, but by remembering the concepts, by remembering the formulas, we can directly say that this function is going to be continuous. So that is the importance of understanding the concept, remembering the formulas. Okay, so now let us see how to simplify this. Clear? You just see the solution, that is limit extending to 0 f of x. That is, we know that limit extending to 0 tan x by x is going to be equal to 1, and that is equal to f of 0. That is nothing but here LHL is going to be equal to RHL, and that is going to be equal to f of a. This definition of continuity. Okay, so from the definition of continuity, we can say that this function is going to be continuous at x equal to 0. This function is going to be continuous at x equal to 0. Okay, very simple question. If you know the formulas, if you know the concept, from that clearly you can say that this function is going to be continuous. Very simple problem, and I feel that there is no any doubts or any confusions for all of you. Very straightforward problem. So you can expect this type of problems in KCET, but in JEE Mains this type of questions are very rare to ask, but in KCET sometimes they can ask this type of questions. Okay, so good morning everyone. I think everyone have understood this problem. Quickly give me thumbs, smiles, so that we can continue. Okay, quickly come on everyone, and your replies, your involvement is very important. So that's why please tell me. We can quickly go for the second problem. You have to give the thumbs, smiles, and you have to just go through the concept. Okay, very good. So now you just go through the second problem. What is the second problem? You just see in the second problem what they have given. They have given if f of x is equal to 1 minus cos of ax divided by 1 minus cos of bx, x is not equal to 0, f of 0 equal to a by b. That means f of 0 they have given. F of 0 is a by b. F of 0 is given. Then at x equal to 0, f is 1 discontinuous, 2 continuous, 3 not determined, and 4 none of this. Okay, so here my dear students, again you must know the 11th class limits concept very clearly. 11th class limits concept very clearly. If you know the 11th class limits concept very clearly, from that you can just say here what is our value. Our value is x equal to 0. What is our value? X equal to 0. Okay, so if I put x equal to 0 here, this becomes cos 0 and this becomes cos 0. So what happens to this? It will be 1 minus 1 divided by 1 minus 1. So it will be 0 by 0. So whenever we come across this type of 0 by 0 form, we say we have to apply L'Hospital rule. We have to apply L'Hospital rule. Okay, so by applying L'Hospital rule, you can just see that here what happens. Limit extending to 0, 1 minus cos of ax divided by 1 minus cos of bx. Okay, so from this you can just see, if I differentiate 1 it will be 0, if I differentiate cos it will be minus sign, minus into minus will be plus sign of ax into a, divided by, here you can just see plus sign of bx into b. Okay, so this is our first differentiation. Clear? So you got a by b. Again if I put 0 here, what happens? Sin 0 is 0, again sin 0 is 0. So again it will be 0 by 0 form if I put limit. So again you apply L'Hospital rule for the second time. So if I apply L'Hospital rule for the second time, what happens? Cos of ax into a will be a square. So again here cos of bx into b will be b square. So now you can apply your limit value, that is x tending to 0. If you put 0 and 0 here, cos 0 is 1, cos 0 is 1. So output will be a square by b square. Output will be a square by b square. Okay, so that means what? You just see, limit x tending to 0, f of x is going to be equal to f of 0, because f of 0 is here not equal to f of 0, because f of 0 is a by b and limit x tending to 0, f of x is a square by b square. So both are not equal, therefore definitely it is going to be discontinuous. Okay, so clearly you can see that LHL is not equal, limit x tending to 0, f of x is not equal to f of 0. So therefore here with this condition you can say that it is going to be discontinuous. So I am using my L'Hospital rule. To solve this particular problem. So very simple way of solving a problem with L'Hospital rule that you can understand. Here I am applying L'Hospital rule for 2 times so that we can differentiate and we can get the answer, that is a square by b square. Okay, so limit value is a square by b square, but f of 0 they have given it as a by b. Therefore limit x tending to 0, f of x is not equal to f of 0. Therefore it is discontinuous. Okay, so this is one of the way of solving this problem. And we can also see another way of also solving this problem. Okay, this is with L'Hospital rule, and you can go with another way of solving, that is you just divide numerator and denominator by x square. And now use the formulas for limit x tending to 0, 1 minus cos of ax divided by x square, and limit x tending to 0, 1 minus cos of bx divided by x square. That is going to be a square by 2 divided by b square by 2. So where 2 and 2 will get cancelled, output will be a square by b square. Which is not equal to f of 0. Therefore the function is discontinuous at x equal to 0, and your answer is going to be option 1. Okay, so very nice problems so that you can understand and you can go through it. Quickly give me the thumbs if you have understood this, so that we can go for the next problem. We have solved it in 2 methods, and you can also go through all 2 methods, because the understanding concept is important. How many problems you solve, that is not important. Understanding the concept is very, very important. So that's why try to solve one problem in as many as ways. Okay, so quickly I can go for problem number 3. Okay, so again here you must know the concept of cos x. Okay, let us see the problem. F of x is equal to x into cos of 1 by x square. X is not equal to 0. F of 0 is 1. Then f of x at x equal to 0 is what they are asking. So see here, f of x is equal to x into cos of 1 by x square. X is not equal to 0. F of 0 is 1. So f of 0 is given, that is 1. Then f of x at x equal to 0 is what they are asking. Okay, so let us see what are the options. 1 left continuous, 2 discontinuous, 3 right continuous, 4 continuous. Okay, so my dear students, here you just see LHL is equal to RHL is equal to f of a. We say this as continuous. Okay, suppose LHL is equal to f of a, but that is not equal to RHL, means it is left continuous. Okay, on the same way, RHL is equal to f of a, but that is not equal to LHL, means it is right continuous. It is right continuous. So these things you may have not studied, no problem, but you can just go through it. Okay, if LHL is equal to f of a, that is left continuous. If RHL is equal to f of a, that is right continuous. And in left continuous, your RHL term will be different. In left continuous, RHL term will be different. In right continuous, LHL term will be different. Okay, so that's why you have to be careful about your left continuous and right continuous. If you know that concept, you can go through this problem. Okay, so now you just see, with these concepts we can go for this problem. Here what they have given, cos of 1 by x square. Anyways, x is not equal to 0, and we know that the range of cos x, is from -1 to +1. The range of cos x is from -1 to +1. Okay, and it is multiplied with x. So here you just see limit extending to 0, x into f of x is cos of 1 by x square. What happens here? Limit extending to 0, x into, this is what? Range from -1 to +1. From -1 to +1. It may take any number from -1 to +1, no problem. But if I put x equal to 0 here, 0 into any term will be equal to 0. 0 into any term will be equal to 0. Okay. So if 0 into any term is going to be 0, means you can just see f of 0 is 1. If f of 0 is 1 and limit is giving us 0, that means what you can say? Limit extending to 0, f of x is not equal to f of 0. Hence what you can conclude? You can conclude that it is discontinuous. You can conclude that this is discontinuous. Okay, so that only you can go through this problem and understand. So once you know the concept, no problem. So you just see here what they are telling. They are telling the same thing. They are applying the limit for x. They are applying the limit for x, as well as they are applying the limit for cos of 1 by x square. So next what happens here? The limit of this term is going to be 0. And here you can just see this is in between -1 to +1. The range of cos is in between -1 to +1. So 0 into this term, definitely it is going to be 0. So you can just see that it is going to be discontinuous. It is going to be discontinuous because f of 0 is 1 and limit extending to 0, f of x is equal to 0. So therefore limit extending to 0, f of x is not equal to f of 0. So therefore definitely we can say that this function is discontinuous. So therefore our option 2 is going to be the right answer. Our option 2 is going to be the right answer. Clear? Okay. So I think everyone have understood this. So we can go for the next problem. Clear? Okay. So the next problem is f of x is equal to cos 3x minus cos 4x divided by x into sin 2x. At x is not equal to 0, f of 0 is 7. At x is not equal to 0, f of 0 is 7. That means f of 0 term is given, that is 7 by 4. F of 0 term is 7 by 4. Now at x equal to 0, what happens to your limit extending to 0, f of x? We have to check. Okay. So what are the options here? One is continuous, second one is discontinuous, third one is not determined, and fourth one is none of this. Okay, no problem. So from this we shall go for the solution of this particular problem, and you can just see here you have to apply. Say if you want to apply L'Hospital rule, you have to apply product here, product rule. you have to apply product rule here. So for the differentiation you have to apply product rule and just check it. But my opinion is if product rule quotient rule comes, L'Hospital rule becomes little bit lengthy. Okay, so that's why here quickly you use cos A minus cos B formula, cos A minus cos B formula, so that it will be very simple. You can also go through L'Hospital rule, no problem, but my opinion is L'Hospital rule, here you have to apply product rule. So sometimes you may go wrong while solving product rule and all, but no problem. I will go for the formula of cos of A minus cos of B. Okay, so here I will apply cos of A minus cos of B formula. So by that I will get 2 times of sin 7x by 2 sin x by 2 divided by x sin 2x, x into sin 2x. Okay, so now what I will do, I will divide the numerator by x and I will divide the denominator by x. I will divide numerator by x and I will divide denominator by x. Okay, so from this here you can just see you have to multiply here 7 by 2 and you have to divide here 7 by 2. So that here you have to multiply 1 by 2 and divide it by 1 by 2. Okay. Okay, so here you can just divide by 7 by 2 and multiply by 7 by 2. Here you just multiply by 1 by 2 and divide it by 1 by 2. So therefore this term, that is limit extending to 0 sin of 7 by 2x divided by 7 by 2x will become 1. On the same way, limit extending to 0 sin of x by 2 divided by x by 2 will be also 1, but this 7 by 2 and 1 by 2 will remain as it is. 7 by 2 7 by 2 into 1 is 7 by 2, 1 by 2 into 1 is 1 by 2, and in the denominator also same thing. Here you just multiply by 2 and divide by 2, this term becomes 1. So here you can just cancel this, 1 into 2 is 2. Clear? So if you go for simplification, it will be just 7 by 2 into 1 by 2 divided by 2, because you can just see here these two terms will become 1, here this term will also become 1. So therefore the remaining terms are what? 7 by 2 into 1 by 2 divided by this term is 2, and outside we have already one term constant, that is 2. Clear? So therefore you can just see answer will be 7 by 4. The answer will be 7 by 4. And you have also seen that they have given f of 0 is also 7 by 4. They have given f of 0 is also 7 by 4. Now limit extending to 0 f of x is also 7 by 4. So if both the terms becomes equal, you can say that f of x is continuous at x equal to 0. If both the terms becomes equal, therefore you can just say that the function is continuous at x equal to 0. Clear? So I think everyone have understood this. Therefore your option 1 is going to be the correct answer. That is, the function is continuous. That is, the function is continuous. Clear? So all of you quickly tell me, are you following the classes? Are you following this class? Have you understood this? Okay. So quickly I will go for the fifth problem. So now I want answer from your side for the fifth problem. Because already I have solved one problem of this type. So quickly try to solve it and tell me the answer. Quickly try and solve it. I think you can solve it because already I have solved one of the problem of this type. So quickly tell me answer. Okay. You can tell me the answer for this. I know. Quickly tell me answer for this so that we can go for the next problem. Already we have solved one problem of this type, that is limit extending to 0 x into cos of 1 by x square. I think we have solved this. I think second or third problem, there we have solved this type of problem and I have explained it. So quickly tell me what is the answer for this particular problem. So just tell me which option is right. Okay. So here you can just see the range of sine of 1 by x will implies you from -1 to +1, from -1 to +1. Okay. So therefore this is going to be the finite value and x is 0. So 0 into anything will be 0. 0 into range, that is from -1 to +1, will become 0. Therefore that is equal to f of 0. That means limit extending to 0, f of x is equal to f of 0. Suppose if we come through this, see here, f of 0 is also 0, f of 0 is also 0, and f of a is also 0. Therefore this is continuous. Okay, that is option 1. Very good. So most of you have given the right answer. Very nice. No problem. Quickly we can go for the next question, that is problem number 6. Okay, so very important problem, because with this problem I am explaining one of the important concept that may help for you in competitive exams like KCET, NDA, AFCT as well as JEE Mains, because with this problem I am going to one of the very important concept that you have not studied, okay. So that you have to concentrate and try to make the notes of this. Okay, so see here, f of x is the given function as 1 plus tan square x square to the power of 1 by x raised to 4 is continuous at x equal to 0. Then f of 0 is what they are asking. See, they have given it is continuous. At x equal to 0 and they are asking f of 0 is what. Okay, so to identify what is f of 0, so first let us see what happens if I put 0 here. If I put 0 here, you just see x value will be 0, tan 0 is what, 0. So therefore it will be 1 plus 0 to the power of 1 by 0. That will be 1 to the power of infinity. So whenever the function comes in the form of 1 to the power of infinity, there is one important rule. Okay, so what is that important rule? You just see. So here f of x is continuous at x equal to 0 is given and limit extending to 0. You just see this term becomes 1 to the power of infinity. If the function limit extending to a, f of x to the power of g of x becomes 1 to the power of infinity, we have to solve it as limit extending to a f of x to the power of g of x equal to e power limit extending to a f of x minus 1 into g of x. So this is our important formula. Okay, so whenever it is in the form of 1 to the power of infinity, limit extending to a f of x to the power of g of x, becomes e power limit extending to a f of x minus 1 into g of x. f of x minus 1 into g of x. Okay, so this rule you have to apply. This rule you have to apply. Here f of x is 1 plus tan square x square. F of x is 1 plus tan square x square, and you can see g of x is 1 by x raised to 4. This is f of x and this is g of x. Clear? So now what we have to write? F of x minus 1. What we have to write? F of x minus 1 into g of x. F of x minus 1 into g of x. Clear? Okay, no problem. What happens? You just see to the next step. Now I will write f of x minus 1. So if I write f of x minus 1, this becomes very simple. This becomes very simple because plus 1 minus 1 will get cancelled. Plus 1 minus 1 will get cancelled. Tan square x square 1 by x raised to 4 will remain. So tan square x square divided by x raised to 4, I can write it as x square whole square. So now this you can write it as tan x square divided by x square whole square. Okay, so that is what I am going to use. See this particular step I am using here. Okay, so now we know that as limit extending to 0, tan square x square whole square will become 1, because limit extending to 0, tan x square divided by x square whole square will become 1. Okay, so if this becomes 1, if this complete term becomes 1, what will remain? E to the power of 1, that is nothing but e. That is nothing but e. Okay, so our answer is going to be equal to e. Our answer is going to be equal to e. Clear? Everyone quickly tell me, very important thing, the formula, that is, if it is in the form of 1 to the power of infinity, e to the power of limit extending to 0, you have to write it as f of x minus 1 into g of x. Please remember this technique, very important. This all are the techniques that you have to remember for before going to the competitive exams. So please go through it and please understand it. Again, after the end of class, you just make the notes of it and try to solve some more problems on that, so that it will be very easy. Okay, so our option is going to be 1, that is E. Our option is going to be 1, that is E. Okay, so now quickly we can go for the 7th problem. All of you, are you following the class? Are you understanding this? Please tell me, are you understanding this? Now I am going for my 7th problem. Now I am going for the 7th problem, where I am going to solve if f of x is equal to e power kx minus 1 sin kx divided by 4x square, x is not equal to 0, f of 0 is 9, is continuous at x equal to 0, then k equal to what? Okay, so no problem. Here you must know the result, limit extending to 0, e raised to kx minus 1, or here let us don't use k term. You must know one important result, that is e power x minus 1 divided by x. Okay, so you must know this result. This is equal to 1. On the same way, limit extending to 0, sin x by x, that is also equal to 1. Clear? Okay, so if these two terms becomes 1, using that result you have to solve. Clear? So see, you just remember these two results now, because I am going to use those things in this problem. Here first option they have given it as plus or minus 2. Second option they have given it as plus or minus 6. Third option they have given it as plus or minus 8. Fourth option you have given just it as plus or minus 4. Okay. So now by taking this, they have already given it is continuous. So we can consider this, that is limit extending to 0, f of x is equal to f of 0. So see here, I have taken our given particular f of x. This is given. Now what I will do, I will multiply k and I will divide k. I will multiply k and I will divide k. So this term becomes what? This complete term becomes 1. This complete term becomes 1. 1 into k, 1 into k. Okay. So see this, 1 into k is k, 1 into k is k. K into k is k square, and you have 1 by 4. If I multiply 4 on this side, it will be k square equal to 36. Therefore k will be equal to plus or minus 6. K will be equal to plus or minus 6. Clear? So now k is going to be equal to plus or minus 6. So that is our option 2. Okay. So here the important thing, note down, that is limit extending to 0, e raised to x minus 1 divided by x is 1. Okay. So now we can quickly go for the 8th problem. We can quickly go for the 8th problem, that is, if f of x equal to root of 1 plus sin x minus root of 1 minus sin x divided by x is continuous everywhere. They have given that it is continuous everywhere. Then what is f of 0? Then what is f of 0 they are asking. 1, second option 2, third option 3, and fourth option is 4. Okay. So please try this and try to tell me the answer. Quickly try this, because the problem is very simple. Problem is very simple. So please quickly try this and give me the answer. Quickly try this and give me the answer. Clear? So please quickly try this and give me the answer. Okay. So anybody got the answer? See, they have given continuous, so therefore f of 0 must be equal to limit extending to 0 f of x. So next you can just see, I will rationalize this. I will rationalize the numerator. I will rationalize the numerator. So therefore I will get 1 plus sin x minus of 1 minus sin x. 1 plus sin x minus of 1 minus sin x. Okay. So by getting 1 plus sin x minus of 1 minus sin x, you can just see that here plus 1 minus 1 will get cancelled. Sin x plus sin x will be 2 sin x. And here you have already x, no problem. So therefore you have got 2 sin x, and this x I have written here, sin x divided by x. Clear? So now you just see, limit extending to 0, sin x by x is going to be 1, so 2 into 1 is going to be 2. Here if you put sin 0 is 0, sin 0 is 0, so root 1 is 1, you will get 2 divided by 1 plus 1, so that is 2 by 2 is 1. Okay. So therefore option 1 is the right answer. Option 1 is the right answer. Okay. Clear? So problem is very simple. That's why I asked all of you to quickly solve it and give me the answer. Therefore answer here it is 1. Answer here it is 1. Okay. So now quickly I can go for problem number 9. Okay, so my dear students, already I have explained this concept. So now what they are telling, f of x is continuous at x equal to 0. F of x is continuous at x equal to 0. What is f of 0? They are telling. See, I will give the hints. If it is continuous, limit extending to 0, f of x is going to be equal to f of 0. Okay. So the given function is in the form of limit extending to 0, f of x to the power of g of x. So already I have explained one of the important trick for this, so that you can just see, by taking x value as 0, this becomes 0, this becomes 0, 0 plus 1 is 1, cot 0 is infinity. So it is in the form of 1 to the power of infinity. If it is in the power of it is in the form of 1 to the power of infinity, it will be e to the power of limit extending to 0, f of x minus 1 into g of x. Okay. So now from this you can just see, I have given all the tricks, I have explained all the tricks. So with that you can quickly get the answer for it. Okay. You can quickly get the answer for it. So please try to get the answer for it. No problem. Okay. Here you just see what happens. This is in the form of 1 to the power of infinity. So I will write it as f of x minus 1. So here you can just see f of x is x plus 1. So f of x minus 1 plus 1 minus 1 get cancelled. Here cot x can be written as 1 by tan x. Cot x can be written as 1 by tan x. 1 by tan x multiplied with x will become x by tan x. So as extending to 0, this will become what? As extending to 0, this will become 1. Okay. So therefore e raised to 1. E raised to 1 is what? E. Clear? So option is 1. Okay. Clear? So option is 1, that is E. Clear, students? So quickly I can get your feedbacks from all of you. Very good. Some of you got the right answer, that is E. Clear? Okay. I will go for the 10th problem. So quickly tell me which method I have to solve. Quickly tell me from which method I have to solve. If you tell me from which method, so that I will also get one hint that you are also understanding the problems. Quickly tell me which method I have to follow. Which method I have to follow. Okay. Okay, you just see here what happens for this particular function. Cos pi by 4 minus sin pi by 4 divided by cos of 2 times of pi by 4. This will be cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2 divided by, you can cancel this, it will be cos pi by 2, that is 0. Okay, so 0 by 0, we have to go for L'Hospital rule. We have to go for L'Hospital rule. So using L'Hospital rule, you can just simplify it and get the answer. So see here, differentiate this minus sin x, differentiate this cos x, differentiate this minus 2 sin 2x. Okay, so you just apply x equal to pi by 4, x equal to pi by 4, that will be 1 by root 2, 1 by root 2. Here you apply pi by 4, this will be pi by 4, it will become pi by 2, sin pi by 2 is 1, minus 2. Okay, so from this you can just see How to simplify it? By using L Hospital rule. Okay. See this. They also have got the same result, that is minus 2 by root 2 divided by minus 2. So minus 2 will get cancelled. 1 by root 2 will be the answer. Okay. So plus 1 by root 2 is going to be the answer. That is option 1. Option 1 is the correct answer for this particular problem. Clear? Quickly, my dear students, you can just see that is option 1 is the correct answer. Option 1 is the correct answer. Clear? Okay. So all of you quickly tell me, are you understanding the concepts? Are you understanding the problems? So option 1 is the right answer. E1. Okay. Option 1 is right answer. That is 1 by root 2. So now let us go for problem number 11. Okay. So just see the problem number 11. If f of x is equal to e to the power of 1 by x square divided by e to the power of 1 by x square minus 1, x is not equal to 0, f of 0 is 1, f of 0 is 1, and f at x equal to 0, f at x equal to 0, continuous, discontinuous, not determined, none of this. Okay. So for that you can just see they are applying limit for this. Okay. So take e to the power of 1 by x square common. See here, take e to the power of 1 by x square common, that will be e to the power of 1 by x square multiplied with 1. Here e to the power of 1 by x square multiplied with 1 minus 1 by e to the power of 1 by x square. You can cancel these two terms. So now you will remain with 1, this term, divided by 1 minus, you just see 1 divided by e to the power of 1 by x square can be written as e to the power of minus 1 by x square. E to the power of minus 1 by x square. Okay. So now as extending to 0, this term becomes 0, because if I put 0 here, 1 by 0 is infinity, 1 by infinity will become 0. Okay, so this will be 1 by infinity, so that this term becomes 0. You just see 1 by 1 will become 1. So already they have given f of 0. Already they have given f of 0. Okay. So f of 0 is what? F of 0 is 1. Clear? Therefore, our answer will be continuous. Therefore, our answer will be continuous at x equal to 0. Our answer will be continuous at x equal to 0. Okay. So all of you quickly give me thumbs, smiles if you are understanding, if you are following the problems. And here you just be careful of this. It is 0. Okay. Option 1 is the right answer. Okay. So I think you can give me the hints now. So just you give me the hints for this problem. So the hints that what you give for me, I will follow that hints and I will solve it. Okay. Because already we have solved the previous problem, 11th problem. From that 11th problem you can understand how can you solve this problem, and already you know what is left continuous, already you know what is right continuous. So that's why you just give me the hints. In the first step what I have to do. In the first step what I have to do. Anyone quickly tell me. So in the RHL what I will do, I will take e to the power of 1 by x common. I will take this e to the power of 1 by x common. Okay, so I can cancel these two terms by taking e to the power of 1 by x common. So now 1 by 1 e to the power of 1 by x plus 1 by e to the power of 1 by x, you can see that this term becomes 0, this term becomes 0. Okay, because they are going to be in the form of 1 by infinity. So we know that 1 by infinity is 0. We know that 1 by infinity is 0. 0 plus 1 will be plus 1. 0 minus 1 will be minus 1. Plus 1 divided by minus 1 is minus 1. Okay. So from this, now you just see that it is going to be minus 1 for RHL. It is going to be minus 1 for RHL. And let us see now LHL. Again same. We will take e to the power of 1 by x common. If I take e to the power of 1 by x common, now it is going to be 1 plus 0 and 1 minus 0. 1 plus 0 and 1 minus 0. Okay. So therefore, you can just see that it will be 1 plus 0 and 1 minus 0. Therefore, this is going to be plus 1. This is going to be plus 1. Clear? So you can see LHL is plus 1, RHL is minus 1, and in the problem they have given that f of 0 is equal to 1. F of 0 is equal to 1. So now LHL is going to be equal to f of 0, but that is not equal to RHL. So here it is going to be left continuous. Here it is going to be left continuous. Okay. So therefore, option 1 is the right answer. Option 1 is the right answer. Okay. Because your LHL is equal to f of 0. They have given that f of 0 is 1. We have got LHL, that is also equal to 1. But RHL is minus 1. RHL is minus 1. Okay. So therefore, left continuous is your answer. Left continuous is your answer. Clear? Okay. So quickly we can go for the problem number 13, and it is very simple. You just see, and answer will be equal to 0. Therefore, it is continuous. The same as we have solved previously. You can just see that it is very simple, so that you can just go through it. So therefore, answer is going to be continuous. So quickly I will go for the 14th problem. Okay. See the 14th problem. In the 14th problem, they have given that f of x is greatest integer function. F of x is greatest integer function. Okay. So already you know that greatest integer function is not continuous, at any integer, we know this. Okay. So but see here, they are asking left continuous, they are asking right continuous. No problem, none of this. Okay. So continuous is going to be deleted. It may be left continuous, it may be right continuous, and it may be also none of this. Clear? So for that, you just see what happens with LHL. See here, f of x, RHL you can just see, for RHL limit extending to 2 plus. That means this is 1, this is 2, this is 3. This x will be from RHL, means from this side. It will be in between 2 and 3. The greatest integer of in between 2 and 3 is what? 2. Okay. So we know that for every value in between 2 and 3 will be 2. That means greatest integer of 2.1, greatest integer of 2.3, greatest integer of 2.5, all are going to be equal to 2. That we know. Okay. So therefore, RHL becomes 2. RHL becomes 2. On the same way, you just see what happens for LHL. On the same way, what happens for LHL, you just see, again this is 1, this is 2, this is 3. From left hand side means here. So the greatest integer in between 1 and 2 will be what? 1. You can just see that is 1.1, 1.2, 1.3, those all terms will give you what? 1. So LHL becomes 1, RHL becomes 2. That means RHL is going to be equal to f of 2. RHL is going to be equal to f of 2. See here, at x equal to 2 they are asking. So therefore f of 2. Clear? So on the same way, f of 2 is what? Greatest integer of 2 is 2. Clear? So therefore RHL and f of 2 both are going to be equal. RHL and f of 2 both are going to be equal. Therefore it is going to be right continuous. Therefore it is going to be right continuous. Okay students, so you can just see here, your RHL is equal to f of a, but that is not equal to LHL. So in this case we say that is right continuous. Clear? So therefore option 2 is the correct answer. Therefore option 2 is the correct answer. Clear? Okay. So quickly give me thumbs if you have understood this. Quickly give me thumbs if you have understood this. So therefore answer key is 2, right continuous. Clear? And note, remember all integers, at all integers greatest integer function is discontinuous. At all integers greatest integer function is discontinuous. Okay. So now quickly we can go for the 15th problem. Quickly we can go for the 15th problem. In that 15th problem you can just see they have given f of x is equal to mod x divided by x and x is not equal to 0. F of x is given as mod x by x and x is not equal to 0. F of 0 is 1. F of 0 is 1. Then at x equal to 0, is it left continuous? Is it right continuous? Continuous? None of this. They are asking. So here my dear students, please remember the properties of mod function. The properties of mod function. F of x is equal to mod x is minus 1 if x is less, minus x if x is lesser than 0, plus x if x is greater than or equal to 0. Okay. So at LHL it is behaving as negative. At RHL it will behave as positive. At LHL it will have negative nature. At RHL it will have positive nature. Okay. So on that basis you have to solve it. So you now just see on the RHL it is positive. So mod x will become ex. Therefore x will cancel. Answer will be 1. That is equal to f of 0. That means RHL is equal to f of 0. RHL is equal to f of 0. On the same way LHL you can just see on the negative side it will be minus x. On the negative side mod x will become minus x. X will get cancelled. It will be minus 1. So therefore it is not equal to f of 0. RHL is equal to f of 0. LHL is not equal to f of 0. That means it is going to be right continuous. That means it is going to be equal to right continuous. Clear? I think all of you have understood this. It is going to be right continuous. Okay. Therefore, option 2 is the correct answer for this particular question. Option 2 is the right answer for this particular question. Clear? Okay. So all of you, already you have materials with solutions. You solve those things. And this is the extra material that I am providing all of you. So you can also get the PDF of this in the groups. And already you have some material provided by me. So that material you solve it on your own because it is with solution also. And there you can go through more and more number of concepts. So here this is little bit new thing for you, and this will also help more for you. Okay, this will be some extra material for all of you, because already you have one material that you can do on yourself. This is extra material which I am explaining, so that it will also help you, so that it will boost the concepts of you. And in this video classes, after the end of video classes, I will share this PDFs so that you can go through that PDF and you can get that. Okay, and you can get the solutions, no problem. Clear? So now quickly we can go for the 16th problem and we can just solve it, no problem. So they are asking it is discontinuous. They are asking it is discontinuous at which point? It is discontinuous at which point? Okay, so x into sin x, if x is in between 0 to pi by 2, pi by 2 into sin pi plus x if it is between pi by 2 to pi. No problem. So you just see what is f of pi by 2. So f of pi by 2 equals sin. So you can take this x place, I replace pi by 2, x as pi by 2, sin pi by 2. So sin pi by 2 is 1. 1 into pi by 2 is pi by 2. So f of pi by 2 is 1. Okay. Next, you just see this is LHL. This is RHL. For LHL, we should take x into sin x. So that is already equal to pi by 2. Okay. Now I will go for RHL. What is our RHL? Pi by 2 into sin of pi plus x. So pi by 2 into sin of pi plus x. X value is pi by 2. See this, pi plus pi by 2. So that will be 3 pi by 2. What is sin 3 pi by 2? Minus 1. Okay. So sin 3 pi by 2 is minus 1. Minus 1 into pi by 2 is minus pi by 2. Clear? So see this, LHL is not equal to RHL. LHL is not equal to RHL at pi by 2. At pi by 2. So therefore, it is discontinuous at x equal to pi by 2. Okay, students. So it is discontinuous at x equal to pi by 2. Clear? Okay. So if it is discontinuous at x equal to pi by 2, no problem. So your answer will be option 2. Okay. So very simple problem. For LHL and RHL, they have given two functions. So you just simplify it. Very simple thing. And I think everyone are following my classes. Everyone are understanding my concepts. So quickly give me thumbs so that I can end this session. And I will also share the PDF. So with that you can get these notes. But already you have one material, good material. Please try to complete that before you go for KCET, so that it can help you very lot. Okay. So thank you everyone. Take care. Bye. And see you in the tomorrow's class at the same time. Okay. Thank you. Bye bye.